So last time we talked about solving system of linear equation in two variables. Today we're going to use that system to our advantage to solve some word problems. These are very common in chemistry. This example that I picked. The next example would be common for if you major in business. There are a couple of common examples. There are more examples in the book. You can read through those as well. So here, first example is a hospital uses a 15% bleach solution to disinfect a quarantine area. Okay, so we have a certain amount of 15% bleach solution. We want to figure out some properties about it. So here it says how much 6% bleach solution. So this is one of the variables that we need to figure out. How much? I call it x. X is the amount of mixture of 6% solution. Must be mixed with 18% solution. So the amount for the 18%, call it a new variable, y. And what do we want to make? We want to make 50 liters of that 15%. So the amount that you get from adding x and y should be 50 liters. So if you add the mixtures together, you should get 50 liters in terms of amount. But the percentage, you have 6% of that x amount. So that is 6 divided by 100, which is 0.06 times x. This is the percentage of the solution for the variable x. And the percentage for the variable y would be 18 divided by 100, so 0.18 times y. This is the amount of the pure bleach that you get from each solution. You'll get 6% of x and 18% of y. If you add these two mixtures, what do you expect is in total? Is 15%. But 15% of what? 15% of 50. So 15% times 50. Parentheses. There we go. That's what we want. That's what we expect to get. Okay. So now we want to figure out what is x and y. So I'm going to write the equation. What do you have? X plus y. If you add those two, you should get 50. And the other one is 0.06 x plus 0.18 y. Should end up with 0.15 times 50. You can simplify. So now you have two equations with two variables. This is the system of equations that we set up. I'm going to simplify it a bit. Normally, I don't want to deal with these decimal values. So what I do is, let's maybe multiply, first let's multiply this phenomenon, this second equation, simplify it a bit. You'd still have 0.06x plus 0.18y equals 50 times 15. 5 times 1.5 is 7.5. 7.5. Okay, so if you multiply 0.15 by 50, you'll get 7.5. Okay. I want to make the coefficients to be the same for variable x. I'm solving the system of equation. I want to make these coefficients to be the same. One has coefficient 1. What do I do is, first, actually, I don't want to deal with decimals. So I can multiply a 10, make these numbers a bit better. Here I will write multiply a 10 to the second equation. Instead of having such a small values as decimal. I just want to show you that you can rescale it and it doesn't change the equation. 10 times 0.06 is 0.6x. 10 times 0.018 would be, you give it some space this way. You write them underneath each other. X plus y equals 50. 0.6x plus 1.8y equals 10 times 7.5 is 75. Okay, now it's much more reasonable to deal with these numbers than originally 0.06. Okay. You can multiply another 10 if you want. You can get rid of the decimal totally. But now I can multiply maybe 0.6 to the first equation and 1 to the second equation. Maybe negative to the first equation, just to make sure the coefficients are the same. So what do you get? You'll get negative 0.6x minus 0.6y equals minus 0.6 times 50. That is 30, negative 30. Your second equation would be 0.6x plus 1.8y equals 75. Okay, if you add the equations together, what we get is the x's will cancel out, so you get 1.8 minus 0.6, 1.2y equals 75 minus 30, 45. So what is y? It's 45 divided by 1.2. And you can simplify. So this is 450 divided by 12. You can divide by 4. This is 450 divided by 12. Maybe I should use a calculator. 1 second. Where is the calculator? Okay. 45 divided by 12. That's 37.5. So here you will get 37.5. You didn't really need this middle. I was hoping to use fraction, but 37.5 is good. So I have amount of x, 37.5. Sorry, y. What is x? X and y together, they should end up to 50. So 50 minus 37.5. 12.5. So the x is 12.5 liter, y is 37.5 liter. And I answered the question. That's how much of each mixture you need to get a 15% bleach solution. It's just the setup that is important. Here's another example. A storage company rents its units for 120 per month. These are the important data. The company has a fixed monthly cost of 2,100 and variable costs of 50 per unit. Okay, so the question here, there are multiple questions. First part, write a cost function that represents the amount of cost that the company has for X unit. So X is the number of units. The cost, the X. What is the cost? The cost is, this is a fixed cost. You always get charged. So this is constant, 2,100. This is what you need to pay. Constant. And you have a variable cost. This is the air conditioning service. And how much do you pay? The cost of each unit is $50. So you'd have, if you make 1 unit, it costs $50. If you make 2 units, it costs 2 times 50. 3 units, 3 times 50. So I'll get cost 50 times number of units, 50x. So this is the cost function. 2,100 plus 50x. Depending on the number of units, which is x. Okay, this is part A. Nothing complicated. Part B, they ask you what is the revenue function, and they use Rx to show it. So what is revenue? Revenue means the total amount of income. The total amount of income would be how much you're making by selling those. So here, each unit will be sold for 120. That's each unit will be rented per month for 120. So what is the income per unit? It would be 120 times x. That is the total income. If they ask you to find out how much is the profit, what would be the profit? The profit would be total income minus the cost. So you'd get 120x minus 2100 plus 50x. This is in case if they want the profit. This is how you calculate the profit. The total income minus the costs. Okay, but in this case, they just ask for the revenue and the cost. And what they want is determine the number of units that must be rented in a month for the company to break even. So what does it mean? It means if you want to break even, you want to have the cost and revenue to be equal to each other. The amount that you're spending equal to amount that you have as an income. That's the cutoff. So what it means is you want the CX and RX to be equal to each other. So you would have 2100 plus 50x equals to 120x. Some cases, instead of writing C and R, what they write is Y. So you have two variables, Y equal to that, Y equal to this one. But in this case, you don't really need to change it to X and Y. If you understand the question, you don't need to go to that system of equation, because this is basically a system of equation. Y equal to 2100 plus 50x and y equal to 120, and you want to solve this system of equation. But instead of solving the system, you can simply say, if I want to break even, the cost and revenue must be equal to each other. Kind of the substitution that you're doing. You're replacing y. These y's must be equal to each other, therefore these two must be equal to each other. And you solve this, what you get is 50x minus 120 would be 70x equals 2100. Divide both sides by 70, x would be 30. So it means that you need to make 30 units. The company needs to make 30 units to be to break even. After that, it would be profitable. Whatever they sell, they're gonna make money out of it. Before less than that, they're gonna lose money because the cost is more than the income. Okay, it's just an example. I picked this one just to mention that there is cost and revenue function. Do not get confused. Most of the examples relating to system of equation similar to the first one, to this one. Okay, so here, this is the solving system of equation in 3 variables. We've talked about 2 variables. 3 variables is exactly the same as 2 variables, but it's going to be more steps to solve this system because you have more variables to deal with. Before I get into doing an example, I want to give you an idea what does it mean. 3 variables. 3 variables would be x, y, and z. So you'd have an equation something like 2x plus 3y minus z equal to 5. It's very similar, if you ignore the z, very similar to the linear equation in 2 variables. But with the z now, it has 3 variables. That means if you draw the axis, you should have 3 axes. Instead of only x and y, you should have 3 axes. This is a 3-dimensional space. That's why I have this drawing. If you look at the corner of a wall, this is what you have is you have 3 corners. Each axis creates a corner. And the solution to this system of equation is a plane. Instead of being a straight line, now it's a plane. It's like a piece of paper, continuously going on forever in each direction. So if you look at each equation and say, this is the solution to one of the equation, this green paper is the solution to the second equation, black paper is solution to the third equation. So we have 3 variables, we should have 3 equations. So what is the intersection of all those? The green and blue will have an intersection at the straight line. The black will intersect with that straight line somewhere, and it creates a middle point. That point is what you're looking for, the intersection of all 3. You want to satisfy all 3 equations if you have 3 equations. But this is not always happening. So here's some cases that you have. If you have 3 pieces of paper, for example, this first case, do they have any common point? Not really. Each two paper will intersect at the line, but no line, those lines do not intersect. So there is no common point. So you would have no solution for this case because there is no intersection of all three. In the second case, the three papers are parallel, so they will never intersect. Therefore, there is no solution. This third case, two of the papers are exactly on top of each other, but the third one is parallel. Again, you would have no solution. So there are more cases that you will get no solution out of it. And sometimes the papers are aligned this way that they have more than one solution. So here you will have a line as a solution. In the other case, you'll have again line as a solution. And here all three papers are exactly the same. So you'll get the whole paper as a solution set because they all intersect over. So what do you get is, in this case, is you'll have infinite solution. It's not that you need to draw it. When you go through the process, you'll end up with, at some point for these cases, you'll end up with something like 1 equal to 0, false statement. In this case, you'll end up with 1 equal to 1, true statement. So you expect to have infinite solution or no solution. So how to do that, how to solve equation, this is what we're going to do. We go through the same structure that we did. Okay, I'm going to use the elimination method. So I have 3 equations, 3 variables. We always set it up that the x's are underneath each other, y's are underneath, z's are underneath, and the constant on the other side. So this rearrangement is possible always. What I'm going to do is I'm going to make the coefficients to be the same. So it means I'll multiply. Look at the coefficient here. You have 1, 2, and 3. I'll multiply the first equation by 3, the second equation by 6, and the third equation by 2. So I'll multiply 3 here. I'll multiply the second equation by 2 and 3, and the third equation by 2. This is basically what I'm doing. I'm picking the coefficients from the other one. So equation 1, I'll multiply it by the other two coefficients, 1 and 3. Equation 2, I'll multiply by the other two equations, 2 and 3. Equation 3, I'll multiply by 1 and 2. I'll pick the coefficients of x for each one. I'll multiply to the other. So that means I'll multiply the first equation by 3. Second equation, 3 times 2 is 6. And third equation, I'll multiply 2 times 1 is just simply 2. Right? Multiply 3, 6, and 2. What do we get if we do that? I'm going to do that. 3 times 2x, you get 6x. 3 times negative x, you get minus 3x. 3 times negative positive 5, you'll get 15z. And 3 times negative 7, negative 21. Okay, 6 times 1x, you'll get 6x. Here's what I would have rather do. You see the coefficients are the same, exactly 6x. I would have rather to pick one of them to be negative. Maybe the first one to be negative. This way, when you add these, it would be negative, positive, negative, positive. If I add the equation 1 and 2, then the x's will disappear. If I pick the first equation, instead of being 3, I'll pick negative. One of them to be negative. So in this case, it's always optional. Normally, I'll pick the first one. 6 times 1x would be 6x. 6 times 4, 24x. 6 times negative 2, negative 12z. And 6. And you would have 6x again, 4y plus 2z equals negative 14. Okay, the only difference that you would see is at this point. I'll add equation 1 and 2. By doing that, I can cancel out the x's. As well, I will add 1 and 3. Why do I do that? I will reduce the equation by doing this. So if I add 1 and 2, what do I get? If you add the equation 1 and 2, negative 6 and 6x will cancel out. You will get 0x. 3, sorry, this was y, not x. Y. 3y and 24y, you'll get 27y. Negative 15z and negative 12z, you get minus 27z equals 21 and 6, 27. And second equation, second equation is 1 plus the equation 1 and 3 added together. You'll add these two. Negative 6 and 6x will cancel out and be 0x. 3y and 4y, you'll get 7y. Negative 15z and 2z, you'll get negative 13z. And you'll have 21 and negative 14. That is, what is that? 21 and negative 14, that's 7. For some reason, I feel like I've made a mistake somewhere. Let's hope not. But let's double check. I don't want to go. Make sure that you do not make any mistakes as you go on, because if the coefficients are wrong, then you're going to mess up everything. So let's double check. You multiply the first equation by negative 6, negative 3, you get negative 6x, positive 3y, minus 15z, and positive 21. 6 times 1x is 6x, 6 times 4y, 24y, 6 times negative 2z, negative 12z, and 6 times 1, 6. 2 times 3x, 6x, 2 times 2y, 4y, 2 times z would be 2z, and 2 times negative 7, negative 14. Yes. Adding equation 1 and 2, 27y minus 27z equals to 27. Equation 1 and 3 will give us 0, 3y, 7y, negative 15 and 2, negative 13, and 12, that is 7 as well. Okay, that looks correct. Here's what I recommend. I recommend to rewrite this. After a while, you can skip some of these steps. I'm just gonna write them so you will see. There's no x anymore. You'll have two variables now. 7y minus 13z equals 7. You can simplify the equation. For example, equation 1, I can divide everything by 27. By doing that, I will make this coefficient to be much smaller. I can write this as 1y minus 1z equals 1. Divide everything by 27. Second equation, I cannot divide by anything, so I'll keep it as that. If I could divide by 7, I would do that. Otherwise, you have to keep increase the coefficient. That's why I did that. Okay, so let's continue to solve this equation. Now I'll multiply the first equation by negative 7, just to make the coefficient to be equal. You'll have negative 7y plus 7z equals 7. Sorry, negative 7. Second equation becomes 7y minus 13z equals 7. See that now I can add the two equations and I can get rid of y. Negative 7y will be 0. 7z and negative 13z, that is negative 6z. 7 and 7, 0. So I can find out what is z. Z turns out to be 0. Divide both sides by negative 6. If you find one of the variables, then everything would become z. I'll go back one step. Replace z into one of these equations. Doesn't really matter which one. I'll pick the first one. Looks simpler. I'll use that. If you replace z with 0, what do you get for y? You'll get y minus 0 equals 1. So what is y? Y is 1. I found x and y. Sorry, z and y. What is x? I'll go back to the original equation somewhere here. Pick the simplest one. Maybe this one looks simpler. Place y and z in there. What you get is x plus 4 times 1 minus 2 times 0 equals 1. Find out what is x. X equals 4 minus 0 equals 1, so x becomes negative. So I found x, y, and z. Normally, you write this as a tuple. In this case, it's a tuple, 3 inputs. This is the x input, y input, and z. Okay, so if you have these inputs, you can write them that way, or you can say simply x is equals to that, y is that, and z equals. Okay, it looks too much work, so be careful if you're calculating, do not make any mistakes. But the procedures are always the same. You try to get rid of one of the equations by making similar coefficient, you add equation 1 and 2, equation 1 and 3, and then continue to reduce one of the variables and continue get rid of one more variable, and you have a linear equation, solve that linear equation. Here's an example, another example. Here, if you see, the way I wrote this is, since there was no x, I left a space for the x. Here there is no x. As in the second equation, there is no y. I left a gap. That means there is 0 y. It's just for you to see that it's better to rearrange this way. They can deal with the coefficients faster. In case if you have one of the variables if one of the equation does not have a variable, substitution seems to be easier in those cases. So for example, if I have no variable x into the first equation, I'll try to use substitution because it works much faster. So equation 1, z is negative 5y. You still can use elimination, by the way, but substitution turns out to be much faster. In equation 1, x is eliminated. You can use equation 2 and 3 to eliminate the x as well into one of those guys. You can add, subtract the equation top from the bottom. But I want to show you different methods so you can use different methods. So here's substitution, for example. If you use substitution, what you get is z equals negative 5y. So in the other two equations, so equation 2 and 3, ignore equation 1 for the moment. In the equation 2 and 3, instead of z, I can write 5y, negative 5y. So I will have negative x plus 4 times negative 5y equals 0. As well as in the last equation, negative x plus 5y plus 5 times, instead of z, I replace negative 5y equals 0. Okay. So what do we have? We have, add them up, get negative x minus 20y equals 0. Negative x, 5y minus 25y, we'll get negative 20y again, equal to 0. You would notice that the second and third equation turn out to be in terms of only x and y, just because we got rid of z by substituting y into. So now what do I have is two equations, two variables. In this case, if you subtract top from the bottom, you can simply cancel out negative x minus minus x with 0. Negative 20y minus minus 20y, again 0. Right side 0. Does not really matter. So what do I have? This is a true statement always. Does it mean that I have infinite solution? Probably does. So how do I write the solution? I'll go back and check. I picked x, z equal to negative 5y. What is x? I can figure out what is x through this equation. What is x? X equals negative 20y. Okay, so everything now is in terms of y. So what is the solution? My x should be negative 20y. Z should be negative 5y. And y is possible. So remember in the last case when we would write in terms of x or in terms of y, here I can write in terms of y and say this is the solution. It's a line, this line, or this is the solution. You can pick y, whatever the y value. It'll give you a specific line. This line, in this case, all the coefficient depends on y. You can pick it based on x if you want. Divide by negative 20. Y would be x divided by negative 20. You can go back to the first equation. Instead of y, right? This is -5 times x divided by -20, x divided by 4. So what is the solution in terms of x? It would be x, y is x divided by -20, z was x divided by 4. This is another way to write it. You can write in terms of z. It's just rearranging them. If you write one of them, this is good enough. You don't need to go through all of those. Okay, so in this case, you have infinite solutions. There will be options again that you would have no solutions just because you'll end up with a false statement. That if you hit a false statement, you don't need to consider anything. You just simply say no solution. The problem is if you have infinite solution, the way that you write it, you should be careful. Okay, depending on what variable I want to use to represent. In this case, you can represent it through x, y, or z. Possible to write it through z as well. The z is an option. What do I get for x? What do I get for y? You can find out what is y. Y would be z divided by -5. So instead of y, I write z divided by -5. Instead of x was -20y. We figured this out through this equation. So x becomes -20 times z divided by -5, since y was that. X equals 4z. So instead of x, I'll replace 4z. Okay, if you notice, here's what you should notice. If you notice from one equation to the other, it just kind of looks like rescaling. If I know y equals to that, then I just rescaled everything by a -20. Divide by -20, I got x divided by -20, x divided by -20, divided by -20, x divided by 4. It's just kind of rescaling the coefficient. There was a relation was only dividing by a constant. But you have to go through this and solve it for the other variables. It's just you need to be careful in case of infinite solution. Okay, I'm gonna stop at this point. Next time we'll continue to solve inequalities for system of equation.